Hi everyone, this is the Chapter 10 test review on trigonometry for Algebra 1B. Remember that your test is tomorrow. I'm going to run through these as best I can. You'll also find a link underneath this video for just a printed out answer key if you wanted to just check your answers instead of watching through the whole video. Okay, so let's take a look at number 1. Number 1 is so simple that you're all going to think it's really hard. All I want to know is what sine of A is looking at this triangle. Well, angle A is this one here, okay? So, and sine is opposite over hypotenuse. So opposite from A would be the 6, and the hypotenuse is across from the 90, so that would be 10. So sine of A would be opposite over hypotenuse. So I would just write sine of A is 6 over 10. And that's literally all I wanted you to do here. So cosine of A, from angle A again, cosine is adjacent over hypotenuse. So that would be 8 over 10. Let's see if I can squeeze it all in there. And tangent of A would be opposite, which is the 6, over adjacent, which is the 8. So that would be 6 over 8. Okay, so again, literally, that's all I wanted you to do was set up those fractions. Now sine of B, now we're going from angle B, the opposite would be the 8 over the hypotenuse. Now remember, the hypotenuse doesn't change, so the hypotenuse is still 10. Okay, so sine of B is 8 over 10. So notice all four of these are going to end up sine of A, cosine A, sine of B, cosine B. They'll all have 10 on the bottom because the hypotenuse is 10 no matter what. Okay, cosine of B would be the adjacent, which is the 6. Adjacent over the hypotenuse, so this one would be 6 over 10. And then tangent of B, here's angle B. Tangent is opposite over adjacent, so this one would be 8 over 6. And we talked about this in class a little bit when we talked about those properties. You should see that sine of A and cosine of B match, as do cosine A, sine B. And then these two are inverses of one another. So 6 over 8, 8 over 6. So that's a way for you to know that you did it correctly. Okay, moving on. Number 2. Number 2 says, suppose you were given the measure of angle A. So I'm going to go ahead and mark here that in this scenario, we would know the measure of angle A, and we want the length of side C. Now remember, side C is across from angle C. So this would be side C. And then we're asked to find the length of side A. Side A is going to be across from angle A. So this is what we're trying to find. So if this was our angle, that would make this the opposite. That would make this the hypotenuse. So opposite and hypotenuse should leave you to use sine. And then for your reason why, I would say something along the lines of because you have the hypotenuse and you need the opposite. Sorry, my handwriting on this is not the greatest. Okay. Okay, so you have the hypotenuse, you need the opposite side. So question 3 is very similar. Let me see if I can clear some of this writing off the triangle. Okay, hopefully that worked. This time you're being given the lengths of sides B and C. So remember, side B would be across from angle B, so this is side B, and side C would be across from angle C, and you're looking this time for angle A. This time you're looking for an angle. So what would you use? Well, first of all, from this angle A, the side B is the adjacent, and side C is the hypotenuse. So adjacent and hypotenuse tell me I'm going to use cosine. But then because I'm trying to find an angle, I also have to keep in mind that that would be an inverse trig function. So I would use the inverse of cosine. And that's what you're going to want to write as part of your answer. I would use inverse cosine because, let me interpret here for you a little bit. Cosine inverse because you need an angle. This right here, the cosine inverse, it's because you need an angle. So needing an angle means to use the inverse. And you have the adjacent and the hypotenuse. Okay, so that's how I would word that. Okay, how does how does the sine of angle A relate to the cosine of angle B? Well, that's what I was writing in up here. The sine of angle A is the same as cosine of angle B. Okay, so pretty simple there. We can just say they're the same. That's all you really have to say, that they're equal. And then number 5, when looking at a trig problem, how do you tell the difference between using a regular trig ratio or an inverse trig ratio? Well, and we've kind of talked about that a couple of times already, but an inverse trig ratio is used for finding a missing angle. So anytime you're finding the angle, anytime your variable is in the angle spot, that's when you're going to end up using an inverse at some point in the game. Which means that the other trig functions, angle, would be used when you're finding missing sides. Okay, so inverse trig for finding angles, regular trig for finding sides. Okay, now these problems, I think I told you in class, these are all right triangles, so we're going to be using SOHCAHTOA for these. Okay, and you may even be helpful to just write at the top of your paper. SOHCAHTOA. SOHCAHTOA won't help you if you can't spell it, so work on that. Okay, so let's take a look at this first one. So here, I have the angle 48. The 9 then is the opposite from 48. And the x, because it's across from the 90, is the hypotenuse. So the O and the H, that would be the sine function, because the O and the H go with the S in SOHCAHTOA. Okay, so I would say sine of 48 is equal to opposite over hypotenuse. It does matter what order you go in. We labeled the 9 as the opposite, so that needs to go on the top, over x. Then I'm going to get sine of 48 out of my calculator, and I get 0.7431 equals 9 over x. Put that over 1. And then I'm going to cross multiply. Some of you are getting really good at just doing the cross multiplying all in one step, and I'm totally fine with that. You would do 1 times 9 and then divide by the leftover 1. So really you're going to end up doing 9 divided by 0.7431. And I end up with like 12.1. And that is correct. Okay? So your trig ratio is kind of what determines whether you'll be multiplying or dividing to get your answer. Okay, looking at number 7. Now number 7, I notice right away that I'm looking for an angle. And that should be a clue to you that I'm going to be using inverse trig for this one. From that x, the 5 is the opposite side, and the 12 is the adjacent side because it's right next to it, and it's not the hypotenuse because the hypotenuse would be across from this 90. So if I'm using O and A, that's tangent from SOHCAHTOA. You probably can't see it on the screen anymore, but from SOHCAHTOA, O and A is with tangent. So I would say tangent of x is equal to 5 over 12. Got to set that up first. And then, anytime you're looking for the angle, anytime this is what's missing, anytime the x is what's missing, you're going to end up using inverse trig. Okay? So in your calculator, I would type in tan negative 1 of 5 divided by 12. And I end up with like 22.6 degrees. And that's x. Okay? Let's take a look at number 8. So I'm going to have to do two separate problems here, one to find x and one to find y. So let's start with x. If 67 degrees is my angle, then the x is my adjacent side, and the 26, because it's across from the 90, is my hypotenuse. So a and h means I'm going to use cosine. So I would use cosine of 67 is equal to adjacent over hypotenuse, so that would be x over 26. And type in cosine 67, and I get 0.3907 equals x over 26. Oops, 26. Put that over 1, and when I cross multiply, I'll be doing 0.3907 times 26, and then divide by 1, but the dividing by 1 really doesn't matter. Ultimately, you're just going to do 0.3907 times 26. And I end up with like 10.15. I guess 10.16. Oh, what the heck. Let's round to 10.2. Okay, I didn't give any specific directions on rounding here, so whatever you give me, I'll take. And now we have to go back and find y. Let me see if I can find some room for y. Okay, so now we're repeating, but we're looking for y this time. So again, I'm going to use 67 as my angle, but this time the y is my opposite side. The 26, notice, is still my hypotenuse, okay, because it's still across from the 90. So this time I'm using O and H, which means this will be sine. So I would say sine of 67 is equal to y over 26. Sine 67, 0.9205 is equal to y over 26. Put this over 1. And again, we're going to cross multiply. So 0.9205 times 26 leaves you with about 23.9. And that is correct. Okay? Okay, just a couple more on this page. Number 9. Number 9, I'm looking for x. I would always start these, if you're not sure which trig ratio you're using, start with your angle, okay? And then ask yourself, what do you have and what do you need? What do I have? I have the opposite, okay, because it's across from the angle. I need the hypotenuse. So whatever you have and whatever you need, those are the two that you're going to use to write your trig ratio. So that's O and H, that's sine again. So I'm going to say sine of 39 equals 7 over the hypotenuse, which is x. Sine of 39 comes out to be 0.6293. Equals 7 over x. Put this over 1. And when you cross multiply this time, you have to multiply the numbers that are across from each other. So we're going to do 7 times 1 and then divide by the 0.6293. And I end up with about 11.1. And that looks reasonable. Yep. X was 11.1 on that one. Okay. And on number 10. Number 10, you have lots of options for this one. Let me see if I can find some more room. Oh, this should be plenty. I'm looking for angles. So right away, that should be a hint to you that I'm going to be using some inverse trig. But I have all three sides, so I can set up any ratio that I want. So let's just look at this angle x. From x, the 12 is my opposite, the 5 is my adjacent, and the 13 is my hypotenuse. So pick. What do you feel like? I think I'm going to do tangent. So I'm going to say tangent of x would equal the opposite over the adjacent, so that would be 12 over 5. And then in my calculator, I would do tan -1 of 12 divided by 5. I end up with like 67.3. Okay, so 67.3 degrees there for angle X. I'm going to clear that off and look for angle Y now. Okay, from angle Y this time the opposite is over here, so this would be the O. The adjacent is this one that's right next to it, so that would be the A. And notice the 13 is still the hypotenuse. Hypotenuse never changes. Basically just the O and the A switch. And again, you can choose any trig ratio you want. So, I don't know, let's do cosine this time. So cosine of Y would be equal to adjacent over hypotenuse, so that would be 12 over 13. So in my calculator, I'm going to do inverse cosine of 12 divided by 13. And I get 22.6. Now here's a quick way to check to see that we got those right. We got 22.6 this time. I think we got 67.3 the last time. And then we have a 90 in there. When I add all of those up, they better equal 180. Because if they don't equal 180, then I don't have a triangle here. And I think this actually, if I add these just how I have it written, comes out to like 179.9. That's just because we rounded off these decimals here. So 179.9, that's close enough to 180 to know that we got it right. Okay, just because I want to try to keep the length of the videos down, I'm going to do a separate video for the second 2 pages in your review. So this covers 1 through 10, and then look for a second video in a little bit on 11 through 20.